Yeah. So as usual, this paper uh, was quite. A CSIR paper was always unpredictable. Okay, and sometimes it was like gate exam, sometimes it was like just exam, isn't it? Sometimes it was like CSIR-NET exam. It contained some lengthy question and all. So I feel this particular question paper is a mixture of some gate question, some gate type question, not this gate exam. Okay, I'm talking about old gate exam, some old gate exam, some formula based questions. Okay, and some concept based question, some lengthy question which you should not choose in the exam hall, and some very simple question. So it's a mixture of all type. And again, why I always say it is unpredictable, because last time all specialization questions were very simple, very straightforward, including this nuclear physics, atomic physics, molecular physics, and all. Questions were very simple from specialization part. So this time they made specialization part questions bit challenging, bit what you call advanced also in specialization question. However, there are some very basic questions. Okay, suppose class 12th level questions and all. So, but that number of questions is very small. Okay, it's a very what you call mixture of different level of question. Some question is just analysis. You don't need to know any theory or any concept to solve some question, isn't it? Suppose there is one question on this standard deviation or variance, and there is one more question on that capacitor given one electron beam. Am I right? Usually we use that one in CRO, cathode ray oscilloscope, isn't it? Those are just analysis question. That's not related to. That didn't require any what you call concept or very big theory to solve those problems. So that is one level. Very what you call analysis or class 12th kind of question, just like that. What you call so chain and pulley question. Okay. Uh, that is one. That is very less actually, maybe three or four in number. Okay, and next one is some gate kind of question. Suppose if you see the question, very less also. Gate means, earlier gate exam they used to ask some formula based question in the gate exam, not last gate exam. Last gate exam they drastically changed the whole what you call pattern. Actually, pattern means again they included multiple answering questions and all. Okay, earlier gate exam contained usually some numerical question which needed formula to be applied. Okay, so there is one or two question like that where you need to apply the formula. So rest of all questions, I think they are. One very simple question on that magnetostatic. Okay, that is usual question that they will ask on magnetostatic. So and rest of all questions are either from the textbook or they are what you call bit. Of CSIR level actually, CSIR exam level. Okay, so that's why by just seeing only some question, don't come to the conclusion that they have asked class 12 level question. One or two question. Okay, or one or two analysis question which doesn't require anything, just like they give in part A, isn't it? So, but most of the questions are, they are what you call of CSIR-NET type only, very old CSIR-NET type only. Maybe new, maybe what you call unique. But you may feel new, or you may feel those questions are new because you haven't solved many books. Okay, those who have who have attended my course. Okay, you have solved some book. Am I right? I'm pushing you to solve some set of books. Okay, but I myself read many other books. Okay, so they are grabbing questions from different textbooks. That's why again, to solve the or to get into what you call 80, 90, 100 marks, so you have to be very conceptually also you should be good, and in the mathematical step also you should be quite well, and no mistake should happen. So that's why it's a very good improvement. That's what I'm saying. Even though some class 12th level question or some very what you call basic question, it's a quite improvement. And as in any other CSIR-NET exam, there are some questions which cannot be solved in exam hall, and again they are not taking care usually. Okay, I mean, after some analysis or after some time, we may come up with some trick or something. But at that exam hall, it's very hard to solve those problems. In CSIR-NET exam, that kind of problems will be there always. And those problems you can always skip. I mean, you don't have to, what do you call, take those kind of challenge in the exam hall. So, I mean, that kind of problems are also there. It's a kind of very good mixture of different level of question. So that's how I see. Uh, now there is one comment in YouTube study material. Please go through our web page and get to know about our learning method. And look at here. I can see lots of questions from the textbooks. Okay, I mean, as I have already mentioned in the web page in our solutions. Okay, so there is one straightforward question from Griffiths electrodynamics. So two conductor embedded. We shall solve that one. Okay, so that is from Griffiths electrodynamics, and that Helmholtz coil also discussed in Griffiths at the end of I think magnetostatic chapter. At the end of magnetostatic, after the magnetostatic chapter, he discussed that one Helmholtz coil concept. So, and one very straightforward question from Jetili on what is that half? What do you call this one? So V is infinity here. Okay, V of x is equal to infinity here. It is minus V naught here. It is 0 here. Okay, speak up. So this is a solved problem in Jetili. I think in the last GATE exam there was one question which needed analysis of this particular potential. Okay, GATE or CSIR-NET, I don't remember. There was one question where he asked three wells, and he is asking what are the energy level order, energy, ground state energy order, increasing or decreasing order. In that particular question, actually, we have analyzed this one. So, but I don't know whether you have remembered that one or not. So, this is a solved problem in Jetili. And along with that one, so I can see lots of other problem from the textbook. Again, if you see one more, what do you call that, question number 38 in my, in our typed question, okay. That Gina-Diode question, that's quite a tricky question that is explained in Boylsted, one of the standard textbook for electronics. What is that? Electronic Devices and Circuit Theory by Robert Boylsted and Neshelke. So it's a straightforward question from that particular book. And another, what is that? Transistor question, Darlington pair. That's also explained in Boylsted. When we see that kind of question, I mean, from specialization and including this Raman spectra question, okay, from and some nuclear physics and particle physics question, they have asked very challenging or in-depth question from specialization. It was very opposite to last time. Last time when we see the question paper, specialization questions were so simple. So I mean, that's what this unpredictable part of the CSIR-NET. And other questions, suppose if you see some statistical physics question, those you can find in YKLim. Those kind of questions, those are MIT, old MIT Princeton question. You can find those kind of questions in YKLim. So that's why, as a whole, I mean, to score, I mean, one complex analysis question, which is very usual one. It was gold GATE question actually. In GATE exam, 2 to 3 times they have asked that question. Cos AX divided by x square plus 1. One quantum mechanics question on linear algebra, usually matrix representation of derivative kind of operator. So that was quite challenging. But I mean, if you know what is operator, what does that operator do, or if you are given some basis how to define a general vector, and if operator operates on that vector, other vector will come, isn't it? So you can use that logic to eliminate options. And somehow, I think, I mean, so this one is usually explained very well in 3 Blue 1 Brown channel. I think I have sent that video during the course that he worked out that derivative operator in that 3 Blue 1 Brown channel. I mean, linear algebra. He explains linear algebra, I mean, for computational or for coding purpose, okay. So there he defined this derivative operator very well. I think in the book, Griffiths, he didn't touch this kind of what you call operator in linear algebra. But once you know what is basis, how to define a vector, and when you operate operator, what kind of other vector you get. If you have that idea, I think you can eliminate the option. So that's why I made two different solutions. One is ideal solution, and other one is elimination of option. Okay. So just check out the web page. We shall solve some of these. Okay. Yeah. Now, let me choose some questions randomly. I hope if you have attended the exam, you already know. I'll choose those, what you call. Uh, Suppose this one, very simple question, Z is equal to, this is 23rd question in our web page, okay? Z is equal to I power, I power, I power, I power, I power, I and all. Is that okay? It will continue infinitely. So this is actually a JEE kind of question. Actually, I mean, only one or two questions are there. Okay, don't feel that by seeing one question, the whole are class 12 level question. It is there. Okay, pick up. So now look at here. If you just put bracket here, okay. So this is also I power I in infinitely, what you call in infinite steps, isn't it? That's why whatever in the bracket it is Z again. So that's why you can write Z is equal to I power Z. And apply log Z, that's equal to Z log I. Okay, he is asking what is 1 by Z into log Z, that's equal to log I. Okay, very simple question. So, but you should get that idea. Or in class 12th, if you have done that one, I think you will get this idea. I mean, how to. I mean, there are many of this kind of questions. Okay, I mean, not only this one in class 12th, as I recall. There are many questions of this kind where you need to define it as original function again, and you need to solve the equations and all. So that's one of the very easy question. And so next thing is, there is one quantum mechanics question. It is question number, I think, 26 here. He has given list of wave function, which one of the wave function expectation value of momentum is 0. He has given one wave function as sine kx. Okay, option 1 sine kx, option 2 e power I kx into sine kx, option 3 e power I kx into cos kx, option 4 sine kx plus e power I kx cos kx. So, I mean, the basic idea is, I think we have already discussed, there was a similar question in old CSIR-NET paper, or some different question, but we use the same concept. What is that one? Expectation P, that's equal to minus I h bar. What is this one? Integral of psi star dou psi by dou x into dx. We can write like this, isn't it? Speak up. Psi star dou psi by dou x into dx minus I h bar, I will take outside. Expectation P. Is that okay? Now, if wave function is real, this I will remain, isn't it? If wave function is real, if this integral, what you call, survives, if integral is non-zero, then what will happen? Non-zero quantity multiplied with minus I h bar, this will be imaginary. What is expectation value? That's the average of momentum measurement outcomes. Am I right? Speak up. That can never be imaginary, isn't it? So that's why if wave function is real, okay, so this integral, what you call, will vanish, so that it will not what you call, make it to be complex quantity. Okay, speak up. So that's why, to make it real, if wave function, I mean, if wave function is real, this integral is definitely real, isn't it? If wave function is imaginary, somehow this will be purely imaginary, and one I will come out, and I into I, you will get a real quantity. Is that okay? Speak up. But if wave function is real, this integral will be real. So then that integral should be 0 to make, what you call, expectation P real. Okay, so that's why again, I think he may be expecting that one. Okay, in the question, because similar question is asked earlier. So only one wave function is real here, isn't it? Speak up. That you can choose that wave function. I mean, since it is not multiple answering question. Okay, speak. So let me first choose some simple question like this, and one more, this linear algebra question, question number 28. All of these problems are solved in that web page. Just go through that web page, or if you just visit our web page, you can find the link to that web page. Okay, AB transpose, okay, that's equal to minus A inverse B whole inverse. Am I right? Pick up. And he has given B is orthogonal. What do you mean by orthogonal matrix? B into B transpose is equal to identity, or B transpose is equal to B inverse. Am I right? Speak up. So now you apply your what do you call AB transpose is nothing but B transpose A transpose. Am I right? Speak up. He's asking what kind of matrix A is. Okay, in the options, what you call A is lower triangular. Orthogonal, symmetric, antisymmetric, and all. Okay, speak up. B transpose A transpose, that's equal to, how do you write this one? Minus of B inverse. A inverse, the inverse is A again. Am I right? Minus B inverse A. So B transpose is nothing but B inverse. Okay, A transpose. Okay, pick up. This B inverse will get cancelled, isn't it? Pick up. A transpose is equal to minus A. A transpose is equal to minus A is antisymmetric matrix actually. Okay, speak up. It's very simple question. And one more question here. I mean, sometimes questions will be simple and tricky. Okay, this 30th question. Okay, why I'm saying this one simple is, again, he has given integral 0 to infinity e power minus x power 2m dx. Am I right? Speak up. And he's asking what is the value of this integral, where m is positive integer. If m is a positive integer, so then what is the value of this integral? Okay, now look at here. I mean, this is not we haven't noted down in our course and all. This was not much required, okay, except one problem in statistical mechanics. Okay, so look at here. I mean, I'm going to use this. I can use this integral to solve other problem in the exam. I can use this integral to solve other problem. So we shall see that one. Okay, we shall see that problem. Okay, so now look at here. What you can do is, what you know here is, look at here. I hope you know this integral 0 to infinity. I have given this one during the course. Am I right? Pick up x power n into e power minus ax square dx. Pick up 0 to infinity. So this is equal to, pick up 1 by 2 into a power n plus 1 by 2, okay, gamma of n plus 1 by 2. This was very helpful in solving many problems, isn't it? This particular integral, where we have taken gamma of half is equal to root pi. Either it can be converted into gamma of integer in most of our problem, okay. It was gamma of integer. Gamma of integer is, suppose if n is integer, gamma of n is equal to n minus 1 factorial. Am I right? If gamma is half integer, you can convert that one into, speak up, gamma of half, that's equal to root pi. Am I right? Speak up. Using this, I think we have applied this integral in many cases. Am I right? So now look at here. I'll put 0 to infinity, n equal to, I'll take this n equal to 0 here. Okay. I'll take again, so e power minus ax square dx. What is this one? Pick up 1 by, or I'll take a equal to 1, because this is very simple. Am I right? X power is 1 here, isn't it? Pick up e power minus x square dx. What is this one? Root pi. Pick up 1 by 2. 1 by 2, a is 1, gamma of half is root pi. Root pi by 2. Okay, speak up. So now you put m equal to 1. Okay, speak up. You put m equal to 1 in this equation. It should be equal to this integral. Am I right? So what is this integral? Half gamma half. Am I right? Speak up. This was gamma half. I have written directly to root 2 pi. Sorry, root pi. So half gamma half is, we know this idea. Am I right? What is this? Gamma of n is equal to n minus 1. Gamma n minus 1. Am I right? Speak up. So half gamma half. I hope if you have solved problem, you know this is gamma of 3 by 2. Am I right? Speak up. So that's why if you put m equal to 1 here in this equation, you should get gamma of 3 by 2. I think only one option will satisfy that one. or they might have taken care while designing the question where you can eliminate the option. Okay, this is also a very simple question because this integral is required for many problems in our syllabus, isn't it? Speak up. So since you know this integral, you again look at here. This is one of the idea of solving the question. If they give generalized question, you take a special case which you know, and you try to eliminate the option. Okay, this is usual idea. I mean, usually one or two question will be like this. Generalized question, you take a special case, okay, and you solve. There was one old CSIR-NET question, I think, on Hamilton-Jacobi theory. What is that? Find the time period of oscillation or something. Okay, given the potential v of x is equal to some a mod x power n or something. Okay, find the time period of oscillation and all. So what you can do is you can take harmonic oscillator. Remember, right? N is equal to 2. Harmonic oscillator, you know that one. Okay, try to eliminate the option because you know everything about harmonic oscillator. Like that, they give the generalized problem. You take a special case which you know and you try to eliminate the option. Usually, you can eliminate the option in this case. This also, I mean, I feel this is very simple question. Speaker. So next, this 32, I mean, 1 by z minus sin z, okay? F of z is equal to 1 by z minus sin z, okay? So what is the, at z equal to 0, this function has a singularity. What kind of singularity it is, okay? You can say at z equal to 0, it is blowing up, isn't it? Speaker. Now, I mean, I don't know whether for you this is difficult or easy question. So, but I thought like that, am I right? I mean, you have to see the, what you call, order of the pole, or you have to find the order of the pole, always referring to Lorentz expansion, am I right? Speaker. So that's why if suppose this has a Lorentz expansion about z equal to 0, z minus 0, let me write on what you call representation of this Lorentz expansion. I'll not expand as a Lorentz expansion because that's not required actually. Okay, let me show this one. Okay, now look at here. So suppose 1 or z minus 0 whole power. So C0, I'll write z minus 0 whole power 0, C1 z minus 0 whole power 1 plus and so on. Okay, all positive powers, and negative power comes C minus 1 divided by z minus 0 plus C minus 2 divided by z minus 0 square plus C minus 3 divided by z minus 0 cube and so on. Am I right? Any function that can be expanded as a Lorentz series, it will look like this. It will have some positive power, it will have some negative power. Am I right? Depending on the function. Am I right? We don't know. We don't have to expand as a Lorentz expansion. But look at here. Just what you call, manipulate this function a little bit. Z minus, what is sin z? Z minus z cube by 3 factorial plus z raised to 5 by 5 factorial plus and so on. Am I right? Speaker. So now 1 by this whole thing is, what is this one? Minus minus plus z cube by 3 factorial, pick up minus z raised to 5 by 5 factorial and so on. Okay. So this is your f of z. Okay. Keep it one side. Now look at here. You have to check whether z is pole of order. I mean, it is a singularity. We know that one. Okay. Speak up. It is a singularity. Whether it is a polar of order 1, polar of order 2, polar of order 3 and all, isn't it? Speak up. Now look at here. If it is polar of order 1, okay, in the Lorentz expansion, only this term will exist. If it is polar of order 1, just understand the Lorentz expansion. So then, if it is polar of order 1, look at here, z minus 0 power 1 into f of z. What do you get? You get c minus 1. Am I right? When you multiply by z minus 0 whole power 1 into f of z, what you get? You get this factor. Rest of all factors are z minus 0 whole power some positive powers. Speak up. And when you apply limit z tends to 0, speak up, only this will remain. If it is polar of order 1. And it will be non-zero and finite. Speak up. If it is polar of order 2, just try to understand this concept. Very generalized concept. Okay, z minus 0 whole square. Okay, if it is polar of order 2. So then, if you multiply by z minus 0 whole power 1 into f of z, okay, limit z tends to 0. Speak up. limit z tends to 0. Now what will happen? You multiply z minus 0 whole power 1. Am I right? These are all positive power. Here the power got cancelled. Here one negative power remained, isn't it? One denominator term remained. When you put z tends to 0, this will go to infinity. Pick up. When this limit will be finite? When you multiply with 2. When you multiply with 2, okay, if it is polar of order 2, your Lorentz expansion will be like this. When you multiply by z minus 0 whole power 2 into f of z, limit z tends to 0. Look at here. So all of these will have positive power. So again, here also you will have positive power because you multiplied with z minus 0 whole power 2. Pick up. And here you that power will get cancelled. You will end up with this c minus 2. I mean, so in this case, it will be non-zero and finite. Non-zero and finite. Is that okay? Figure. So that's why, I mean, this limit, okay, it's a test of the order of the pole. Is that okay? Can you note down this one? Note down. So if limit z minus a whole power n, limit z tends to a, limit z minus a whole power n into f of z, okay? If this limit is non-zero and finite, speak up. If this limit is non-zero and finite, okay, speak up. Now look at here. Suppose if it is polar of order 2, okay, if you multiply with z minus 0 whole cube into f of z. I mean, it was polar of order 2. You thought it is polar of order 3, suppose, okay? So then you just check this limit. This limit will be 0. Speak up. You multiply by z minus 0 whole cube. Here also positive power comes, isn't it? Limit z tends to 0, everything vanishes. Speak up. Z minus 0 whole cube throughout this one. Whole square is there. You have positive power in each and every term. This will be 0. Speak up. So that's why that should not be 0. That should not go to infinity. Am I right? Suppose if you take z minus 0 whole power 1, in case of polar of order 2, what happened? It tend to infinity, isn't it? Speak up. So when this power is order of the pole, okay, then that will be non-zero and finite value. Okay, so then look at here. When limit z tends to a, z minus a whole power n f of z is non-zero and finite, so then f of z has pole of order n, speak up, at z equal to n. So this is purely by understanding the definition of order of the pole. You see, any textbook, order of the pole is defined in reference to Lorentz expansion only. Is that okay? Speak up. So that's why now see this one. I mean this concept you should know to solve this question. I mean, if this concept is known, this is nothing. This problem is nothing. You don't have to do something. Okay, pick up. That's why understand that Lorentz expansion properly. Okay. So and try to apply it here so that look at here when now you can see, isn't it? You can predict now order of the pole, isn't it? Pick up. If you multiply by z cube, okay, or if you multiply by z minus 0 whole cube into f of z, what is this one? Pick up 1 by z cube, 1 by z cube, isn't it? Multiplied with z cube by 3 factorial minus z raised to 5 by 5 factorial plus and so on, isn't it? Speak up. When you take it inside, 1 by 3 factorial, okay? Speak up. Minus z square by 5 factorial and so on, am I right? Now, if you take limit z tends to 0, this is non-zero finite. Speak up. Or you start with z, multiply by z and put z tends to 0. Multiply by z square, put z tends to 0. You can guess. If you do one of this step, you will guess. Yeah, if I multiply by z cube, it will be, if I take the limit z tends to 0, it will be non-zero and finite. Speak up. So try to understand that Lorentz expansion and definition of what you call order of the pole. Okay, speak up. Now I'll not say all of the questions are very easy from this part, but one more question that I point out here. I mean, it's also a kind of class 12th question only, but yeah, you should have a little bit practice from the class 12 to answer this one. Z power I plus I power I and all, and that chain pulley problem. And this problem also, okay, what is this one? The period of oscillation of simple pendulum at sea level and at top of the mountain of height 6 kilometer are T1 and T2 respectively. Question number 40 in my web page, okay, pick up. Now, so at the sea level, okay, and at the top of the mountain, which has a, what do you call, 6 kilometer, okay, height, okay. So at sea level, its time period is T1, okay. At top of the mountain, time period is T2. Is that okay? Speak up. Now you have to, what do you call, what he's asking is, what is the radius of the Earth is given. Look at here. Radius of the Earth is given, that's equal to 6,000 kilometer. Speak up, 6,000 kilometer. Now look at here. You can take your Newton's law of gravitation. That okay. I mean, for simple pendulum, your time period is equal to 2 pi root of L by G. Speak up. So this acceleration, that is because of force. Am I right? Speak up. Can I write that 2 pi root of L by force on that mass divided by mass? Speak up. Why not? So now again we have taken that approximation. I mean, Earth is very big. Okay. I mean, whatever V of x is equal to mg into x or something, whatever you write. Is that okay? Or mg into h, isn't it? Pick up. V is equal to mg into h, isn't it? This is an approximated potential energy. Okay. So if you write V of x is equal to mg into x, okay, when you take the derivative, you will get a force. Am I right? That force is equal to m into g. That's what you write. Am I right? Pick up. On the Earth, wherever you are going to write force is equal to m into g. So that's actually approximated one. Okay, from your Newton's law of gravitation. Now, in this case, since he has given radius of the Earth and all, you take Newton's law of gravitation. Pick up. You have Earth here. So this is sea level. This is mountain. Just imagine. Okay, pick up. This is 6 kilometer mountain. Is that okay? Speak up. So again, this whatever mass you have here. Okay. I mean, sea level means I mean you have taken your pendulum at sea level means that mass is at this position. Then what is this force? Okay. Now mass is at this position. Okay. That mass is at this position. Okay. Now you take radius of the Earth also into it. It's a central force. Am I right? How do you write? So force is equal to minus g, mass of the Earth, mass of the your pendulum bob, okay, divided by, speak up, distance between, I mean distance between the center, the whole square. Am I right? Speak up. So now in this case, what you do is, suppose if mass is at some distance, okay, pick up, mass is at a distance, okay, x from the surface of the Earth, okay. Let me take like this in the generalized situation, okay. So this r is the radius of the Earth, okay. So that is r plus x the whole square, isn't it? Pick up. Force on mass m, okay, at x. Can I say like this? At x. X is the height from the surface of the Earth. That surface of the Earth I have taken sea level. Is that okay? Speak up. So now you can use this formula, am I right? So you need force at sea level, am I right? Sea level, what is this one? Minus g m by r square actually, okay? Pick up. Now force by mass, am I right? That's nothing, that this quantity you need to substitute here, am I right? Pick up. That's equal to minus gm by r square. You take magnitude of this one, okay? Take magnitude of it. You have under root there, okay? Pick up. And you need force at mountain, am I right? Pick up. That's equal to minus gm by r plus what is this one? 6 kilometer, am I right? So this is also given in kilometer, 6 kilometer, the whole square, am I right? Take the mod and divided by m, okay? Pick up, divided by m. So he's asking some ratios here, okay? That's why this gm will get cancelled. You don't have to be worried with that one, okay? So that when you substitute in this time period formula, okay, when you take the ratio and you have to substitute that what you call r value, you have to substitute that 6 kilometer, speak up, you will get the option. Is that okay? Speak up. Also kind of class 12th kind of question. I think this is the third question that I guess, okay, of that kind. So, but this kind of question is quite frequent in just exam. Okay, so you can see this question in just exam. So some students are in classroom, some students are online. You can always ask doubt. Okay, I mean, if you have any question on whatever I am teaching here, you can quickly ask that one. Okay, speak up. I'll move on. So in part C, I feel that capacitor question, capacitor and electron beam. That's very simple one because it's not 5 marks. Am I right? It will not take much time to analyze that question. Okay, speak up. So then one atomic physics question. I mean, if you have done atomic physics well on Hund's rule, isn't it? Very straightforward question. And one more atomic physics question on hydrogen atom and another hypothetical atom using muon and electron. Am I right? Speak up. So there he has taken N1, N2 same. Am I right? The transition between two levels he has taken same in hydrogen as well as in that hypothetical atom. Now the wave number or frequency is proportional to Rydberg constant. Am I right? Speak up. How do you write usually Rydberg constant into 1 by N1 square minus 1 by N2 square? Or 1 by N2 square minus 1 by N1 square. Am I right? That's how you write. When N1 and N2 are same, isn't it? Speak up. It's actually proportional to Rydberg constant. I told you Rydberg constant depending on reduced mass, isn't it? Speak up. So I think that reduced mass comes in the numerator of Rydberg constant. This is what's sufficient. While discussing also atomic physics, I think we have done like this. Am I right? What are the what you call where mass comes? Am I right? In velocity of the nth orbit, in the radius of the nth orbit, and like that in Rydberg constant also. Again, mass is in the numerator or reduced mass is in the numerator. Okay, just check out the solution. Again, I'll not waste much time. So that is also again, if you know that Rydberg, frequency of transition proportional to Rydberg constant proportional to reduced mass. Okay, reduced mass for hydrogen atom is mass of electron only. Am I right? We have studied that one well, isn't it? Speak up. So reduced mass for what you call that hypothetical atom where muon is a nucleus. Am I right? Mu plus is a nucleus. Electron is a what you call revolving. Okay, this is a hypothetical atom. He has given the mass. You need to find that reduced mass. Okay, pick up, and again the ratio. You don't need any other coefficients that comes in Rydberg constant. You need only mass dependence. Okay, so that's also. If you have studied that one, so that's also very simple question. And so this Lagrangian, this normal mode question. Okay. 2 cross 2 matrix, 2 cross 2 determinant solution. Am I right? It's the problem number 59. Finding normal frequencies of normal mode, isn't it? That question was very simple, but calculator was required. Am I right? Can you do without calculator? Anyone? Speak up. Can you do without calculator that 59th question? Again, you have to write kinetic energy matrix. You have to write potential energy matrix. Pick up. And then what is this one? T minus omega square v minus omega square t determinant v minus omega square t determinant is equal to 0. You have to solve for omega square. So 2 cross 2 determinant and 2 roots will be there. 2 omega square you will get 2 what you call normal mode frequencies, but that required a calculator. So that's why in CSIR-NET exam, while designing the question, they will not take care whether you can do in the exam hall or not. Okay, but since it is a competitive exam, you should not be worried with it. You should be in the top of the competition. That's it. Am I right? If a calculator is not allowed, it is not allowed for everyone, isn't it? Pick up. But what will happen is you may go up to that step, you may stuck. Am I right? You may not proceed, isn't it? That would consume time actually. You may go up to that step of this root of this the quadratic equation. Okay, so then you may stop. That will kill your time actually. You can't work out that numerical. Then you may stop. So it's quite difficult to guess, isn't it? Before doing the problem, whether you are going to stuck at that stage or not, if calculator is not given, isn't it? So this skill is also very important in exam. Okay, speak up. Whether this takes too much time, whether it is solvable or not. Okay, so I mean this requires some practice. Okay, this requires some experience, so that you can guess. No, I'll not do this. Nor I'll do it at the end. You keep this problem at the end because it may require calculator. If you guess this one, that means you saved 5 minute time actually, isn't it? Pick up. I mean, you keep this question at the end. Usually at the end, you will not read this question because there will be some more simple question to solve in the paper. So that's why, I mean, leaving some question is part of the competition. Okay, if you spend 5 minutes, that you lost that 5 minutes if you are not what you call uh, uh, choosing any options here. Okay, speak up. So, any other simple question? I think this statistical physics question, that's a very usual question, two-level question. What is this? So 62. So just check out website. Okay, I think I solved most of them. Um, so energies are plus or minus E. Okay, speak up. And he's asking what is specific heat at low temperature. Remember? Speak up. At low temperature, at T tends to 0, what is specific heat proportional to? Okay, he's asking proportionality. Okay. So now look at here. While solving this kind of question, you should have a practice because that paramagnetism question was also two-level question. Am I right? Pick up. There are many other questions in Weik element all. Again, usually again in any books you can find two-level question. Am I right? You should quickly write Z is equal to e power minus beta e plus e power minus plus beta e. Speak up. You quickly write 2 cos hyperbolic beta e. Speak up. We should be very fast in these steps. Okay. Speak up because these are usual questions. That we should not miss anytime. Okay, so then average energy is equal to minus dou by dou beta log of z. Speak up. That's equal to when you apply log of z, log of 2 will be other log of 2 plus log of cos hyperbolic. Only log of cos hyperbolic you need to take care. Okay, minus cos hyperbolic beta e. Speak up. Sin hyperbolic beta e. So into derivative of beta, that's equal to e. Okay, so that's nothing but okay minus e tan hyperbolic beta e. If you have studied that paramagnetism problem well, I think you can write this step directly. So what is next one? Cv is equal to minus kb t square dou by dou beta of average energy. Am I right? Speak up. So now what is the minus kb t square into minus e? What is the derivative of tan hyperbolic? Secant hyperbolic square beta e. So later again write this one in terms of exponential. What is secant hyperbolic square? Speak up. That's equal to plus kb t square into e, isn't it? Into e whole divided by cos hyperbolic square beta e, isn't it? Speak up. So that cos hyperbolic square, I can write it as e power plus beta e plus e power minus beta e, the whole square. If temperature is very small, okay, beta is very high, okay, e power minus very high quantity, that is nearly equal to 0. So this square will remain, this part will remain. You take it to numerator, find the appropriate option. Okay, speak up. So writing these steps quickly, because very many problems are of the same type, two-level system actually. Okay, speak up. I think in Reef he has given one problem on specific heat. What is the nature of this one and all? Okay, what is the nature of specific heat in this particular problem? If calculators are not allowed and question is solvable with the help of calculator or asked, then it will be a bit difficult. Speak up. I mean, but right now we can't what you call fight with them. Am I right? It's not feasible. You just move on. Okay. But it's a kind of, I mean, usually in CSIR-NET exam, they're not taking care while designing the question whether it is solvable in exam hall. I mean, because they know that calculator is not given, am I right? While designing the question, they should design, I mean, in earlier, when calculator was not allowed, they designed the question so that problem can be solved without calculator. Somehow you can take something common or multiply, divide. You can somehow what you call do those numericals actually. Okay, but recently they are not taking care much, but leaving that kind of question is also part of the competition. Okay, speak. So then I feel this problem number 68, complex analysis question, very usual question. So that's also a bit what you call easy. I mean, easy means what you call, you need to go for contour integral actually if you want to solve at that instant of time, or you can have some derivative idea. I think in Gravel he solved similar question. Okay, you can take a couple of derivative, you will get the same what you call integral. Then you can form a small differential equation. That kind of cos ax by 1 by x square plus 1. Okay, you take derivative with respect to a, you will have sine. You'll take one more derivative with respect to a. Okay, that's a complex analysis, am I right? So I mean, I'm saying, I mean, that's how I did in the solution. Okay, in the web page. What I'm saying is, why can't I write I as a function of a? What is this one? Integral minus infinity to plus infinity, cos ax by x square plus 1 dx. Complex analysis is the best way to solve. And once you understand that complex analysis way, it's nothing actually. It's a real part of e power I ax by x square plus 1 integral, isn't it? Pick up. So, and again, in only thing is writing the step may be complex. Okay, that complex analysis step, taking the contour and all. Okay, so if a is, look at here, in e power I ax by x square plus 1 dx. Okay, integral minus infinity to plus infinity. To solve this one, when a is greater than 0, he mentioned clearly, you should take positive, what you call, contour, semicircular contour in the upper half plane only, not in the lower half plane. Okay, for other integral, that is our choice. You can take contour in the upper half plane or lower half plane. Only contour along real axis does matter for us. But for this e power I ax by x square plus 1 dx, okay, for a greater than 0, contour should be taken in the upper half plane only. Usually you take like that. Okay, so that argument is given in Weber. Okay, just see that one. For a less than 0, you should take contour in the lower half plane. Okay, so that you need to remember. I mean, you can do what you call complex analysis way. Now, right now, what I'm thinking, what is come to my mind is, look at, you take I at ISA. Okay, you take di by dA. What is this one? Speak up. Sorry, x sine ax by x square plus 1 dx. No, I'm just thinking, okay, whether any other way. Cos ax, the derivative with respect to a, minus sine ax minus x is outside. I'm thinking if I take a couple of derivative, whether I get the same integral, that kind of idea. So, I mean, but some other way is there, okay, to solve this one. It is there in Gravel, okay. While solving, I think, Fourier transform and all, we have used some trick, okay. I mean, other than complex analysis method, okay. But whatever he is expecting, just to fill out that expectation, I mean, you don't have to, what you call, do more, okay. Speak. And I feel this, what you call, the energy levels, 3 energy level, 2 identical boson, okay. What is the probability of total energy is 3. That's also a very simple question. You can write the partition function. Question number 74. Question number 74. Speaker. So 3 energy levels. Okay, 0, I think E and 2E. Okay, 3 energy level. 0, E and 2E. And what is the probability of getting total energy? 3. Total energy will happen when you have one boson here, one boson here. Okay. There is no other way to get 3E energy. Am I right, speaker? So you again, there is only one possible combination, and you find Z of the, what do you call, partition function of the total 2 boson gas. Okay. So you can write e power minus 3 beta E divided by your partition function. Okay. That's the probability of getting, what is that, 3. Speak up. That's also a very simple question. I mean, in 5 marks, okay, you can do it quickly. You can do it quickly. So last question, I mean, on phase space trajectory. So, I mean, it again, it is given in 5 marks. He may be expecting something, okay? But if you have an experience of solving this phase space question, okay, pick up 75th question. So you can do that one, because again, I have interpreted a lot of ideas. I think those videos are there in YouTube playlist also. In case of phase space question, look at here. If you now, what is the potential curve? You can guess what is the phase space trajectory. But in this case, drawing potential curve is bit, what do you call, challenging also. Okay, in this particular question, potential is equal to ax square minus, pick up, v naught into e power minus 10x, isn't it? Pick up, e power minus 10x. Now, one thing that you know, that this is not, or this can never be, or if you write your energy, okay, energy equation, that's equal to p square by 2m. This is a conservative field, okay. Potential depends only on the position. It's a conservative field, okay. You can have constant energy in this situation. P square by 2m plus here, plus or minus. Both minus, again, potential energy is plus here. Check that out. Lagrangian is given, isn't it? Speak up. Plus ax square plus v naught into e power minus 10x. Okay, speak up. So now this is, I mean, this equation is equation between p and x, am I right? Which decides phase-space trajectory for a particular energy, isn't it? Now this equation is not ellipse, am I right? This will never be elliptical equation. That's why you can eliminate two of those options where he has given ellipse, isn't it? Pick up. So the next one is, again, I have given one idea that, look at here, all ellipse, all curves are closed curves, am I right? You should get one idea that it is a bound state. For bound state, phase space trajectory is a closed curve, okay? So just watch the video that I have mentioned in the web page, okay, about phase space trajectory. I have discussed a lot of ideas about phase space trajectory. If you just digest those ideas, within no time we will answer this question. You don't have to solve. Now look at here. So you should know, again, after seeing those options, okay, where you have closed the trajectory, so this potential has a minimum. It is a kind of bound motion. When bound motion will happen, when you have potential like this, your energy like this, am I right? Then bound motion will happen, am I right? It may not be parabolic, okay. The shape of the curve may be something else, okay, but you have a bound state, isn't it? You have a bound state. Particle is not escaping. It is moving between two positions. Okay, you can guess that one when you see the options, isn't it? Speak up. I mean, without working out the potential. But see the potential properly. It has a minima. Okay, it has a minima. And look at here. And where you have that minima, that you need to point it out. This potential has a minima. That again you have to guess by first derivative and second derivative test only. Okay, speak up. And you don't have to go for second derivative test, because by seeing the option, I can say potential has a minimum, because it should have bound state, isn't it? So that's why I will go only for first derivative test. What is v dash of x? Speak up. A, so 2ax minus v naught into 10 into e power minus 10x. Speak up. So 2ax minus 10 v naught into e power minus 10x is equal to 0. Speak up. Now when you solve it for x, look at the equation. 2ax is equal to 10 v naught into e power minus 10x. I think it's a kind of transcendental equation. Okay, speak up. Or check out whether it can be solved. Okay, so this will happen only for positive x value, isn't it? Speak up. Derivative will be 0 only for positive x value. Check this out. E power minus 10, it will never be negative. So that's why this x will never be negative, isn't it? Speak up. Or if you go for transcendental equation, okay, 2ax is this curve, okay, e power minus x is this curve, it will cut somewhere here. That's the solution of this equation, am I right? Transcendental equation can be solved by graph. Speak up. If you apply log will remain here, x will remain here. Again, I don't think you can solve. Okay, check that out. Isn't it? If you apply log E, again x is equal to some log x will happen. some x power x or something will come. But what I'm saying is, okay, so this solution, I mean, this solution, I mean, it has a derivative equal to 0 for positive x value. That's what you need, okay. So now, so that means potential has a minima, okay, for some positive x value. Pick up. I don't know what is the exact nature of the potential, but it has a minima for some positive x value. Okay, you can check for a second derivative also, but quite lengthy again. Okay, but you just need where its derivative vanishes, there it has a minima. Speak up. Now, what will happen is your phase space trajectory. I mean, suppose if you have what you call different energy. Okay, speak up. Suppose if you have different energies, this is E1, E2, E3 and all. When you decrease the energy, okay, so your phase space trajectory, this shrink will shrink at the position of that stable equilibrium minima. Okay, phase space trajectory will shrink at the, I mean, if you take different energy, he has plotted for only one energy. Okay, but this idea is sufficient to eliminate the option. Just check that option 1, when you keep on shrinking that curve, it will end up with negative x value. Is that okay? Speak up. So check option 2, when you keep on shrinking that curve. So take what you call, so take curve like this, okay? So this kind of curve that he has given, am I right? So take this kind of curve, okay? I mean, this is for lower energy. This is for lower energy. Take this kind of curve, you will end up with a point on positive x-axis. Is that okay? So these two are sufficient to eliminate the option. So second option, if you have taken different energy or lower energy, it will shrink at positive x coordinate. First option, when I mean either 1 or 2, am I right? You have eliminated other 2 options because that's not elliptical equation between p and x, isn't it? So among 1 and 2, you can just take the idea where potential has a minimum at that point, this curve should shrink to a point. If you take lower energy, he has plotted for only one energy, but that is sufficient to answer the question. Okay. Speak up. I mean, I feel this is easy if you have digested that phase space, that particular idea that I have proposed. Okay. So I have taken first harmonic oscillator, then I have taken some other potential, 2 to 3 potential. From all of them, I made one note on that one. I don't know whether you remember or not. Okay. Phase space for a bound state, phase space curve shrink at the point of stable equilibrium. I made this statement actually. That is quite useful in this particular problem to eliminate the option. Okay, speak up. Now let me take up some quantum mechanics challenging questions, and then we shall discuss what kind of qualities were required, okay, for this exam. Okay, I mean, so covering the syllabus is one part, and the other part is, I mean, what should be your attitude? What should be your, what you call, I mean, not only what you call working hard or covering the syllabus, am I right? Something else is required to crack this exam, this competition. We shall discuss about it. Let me solve a couple of quantum mechanics questions. Okay. So this question, I mean, this finite square well, am I right? What is that? It's a solved problem in Jatili. You can just check that out. Where am I missing? Oh, okay. So let me take it like this. So this is x-axis, okay? Speak up. This is 0. This is negative x-axis, okay? Minus x-axis, okay? This is your v of x. It is equal to infinity here. V of x is equal to infinity here. Is equal to minus v naught here. Pick up. Minus v naught here. It's equal to 0 here again. Potential is infinity. Minus v naught, 0 here, okay? And he has taken bound state. Bound state means energy less than 0, okay? So this is a bound state of this particular situation. Now look at here. So since potential is infinity, wave function, what you call particle cannot enter here. Wave function equal to 0. Can I write this one as region 1, region 2, and region 3? Pick up. Region 2 is 0 to A here. Okay, this is A. Pick up. In the region 1, wave function psi 1 equal to 0. Okay, In the region 2, when energy is greater than the potential energy, it is e power ikx plus e power minus ikx or sine and cos. Solution of Schrodinger equation. Okay, pick up. You can write your solution in this one: a e power ikx plus b e power minus ikx. You can convert that one into sine and cos. Sine kx plus b cos kx. Okay, this k in classic, this is a classically allowed region. Am I right? Pick up, which corresponds to positive kinetic energy actually. So root of 2m e minus v of x. Am I right? When energy is greater than potential energy, you define k like this, divided by h bar. Okay, speak up. So, or just solve the Schrodinger equation. Just substitute these things in the Schrodinger equation, solve that one. That's equal to root of 2m. V is nothing but minus v naught e plus v naught divided by h bar. Okay, you have to keep this k one side. This is required. K is equal to root of 2m e plus v naught divided by h bar. In this region, okay, in the second region, I'll take it like this. In the second region, your solution is this one. In the third region, it should be exponentially decaying solution. Okay, I mean, when you solve the Schrodinger equation, you will get either e power, you will get like this. Okay, a b c e power kappa x plus d e power minus kappa x. Okay, I'm using Griffith symbols. Okay, but it cannot be exponentially increasing function because so particle cannot escape here, isn't it? Because it's a bound state. Its probability of finding the particle should decrease when you move towards positive x region. That's why you can, on that physical ground, you can choose c equal to 0. Okay, so that your solution here is equal to d. I mean, I'll write this one as psi 3 is equal to d e power minus kappa x. Okay, since it is classically forbidden region, how do we define that kappa? Root of 2m v minus e actually by h bar in classically forbidden region, but v equal to 0 here. So that's why this kappa is nothing but, speak up, root of minus 2m e divided by h bar. Speak up, v equal to 0. You have to keep these things. Now, I'll make it very simple, okay? So, wave function should be continuous always, okay? Whatever the situation you take, wave function should be continuous. That continuity requires that, look at here. So, if you have cos term, that cos term will not go 0 at x equal to 0. And when x less than 0, it is 0, am I right? When x at x equal to 0 or just x greater than 0, it should start from 0. This cos is not allowing it to, what you call, make it happen, am I right? Or you just apply what you call psi 1 of 0 is equal to psi 2 of 0. Continuity of the wave function at x equal to 0. Speak up. That will give you b equal to 0. Just see the solution manual. If you're not following the step, see the solution in our web page. Okay, speak up. But don't apply derivative continuity. Why? Speak up. Whenever potential has a singularity, derivative is discontinuous. Speak up. So, I mean, on this one, there are many questions, isn't it? Pick up in TAFE or I think in CSI or GATE exam, I think. Okay, speak up. So now look at here. Now, once you choose b equal to 0, your solution in the second part is like this, isn't it? Solution in the third part is like this. Now apply continuity of the wave function as well as derivative continuity, because here potential is finite. Derivative is also continuous. Wave function is always continuous. Is that okay? Speak up. At x is equal to a, when you apply continuity of the wave function, psi 2 of a is equal to psi 3 of a. What you get? Speak up. A sine ka is equal to d e power minus kappa I. Okay. So when you take the derivative, when you put x tends to a, okay, derivative continuity. So psi 2 dash of a is equal to psi 3 dash of a. What is psi 2 dash? A k cos k x x tends to a. Okay, speak up. That's equal to minus d kappa e power minus kappa a. Am I right? Speak up. Take the ratio. Take the ratio. Second one divided by first one. So what you get? Cot ka. Okay, speak up. K cot k is equal to minus kappa. Okay, speak up. And just divide by k, you'll end up with this one. Square this one, substitute this one, you'll get the answer. Don't forget this negative sign. Okay, speak up. So this is 5 marks question. I mean, worth for 5 marks. Okay, speak up. not so lengthy, not so difficult. But you should know solving this kind of problem. I mean, finite square well, and this is question. I mean, this is a part of the question in that gate exam, last gate exam. Part of that one was this one. I mean, you needed this one to analyze that question. So this is a transcendental equation. Again, you have to go for graphical solution here, actually. Okay, I mean, to find the energy eigenvalues here. Okay, that's a different part of the study, but he's asking this kind of equation. Okay, speaker. So if you have some practice, you should quickly choose sine here. Solution is sine plus cos, am I right? You should quickly choose sine. Why you should go 0 here? Then apply continuity of wave function and continuity of derivative at this position. Is that okay? Speaker. So this was solved problem in JTD. And one more problem on time dependent perturbation theory. I solved that one, but it required to solve two integral where you need to remember ground state and first exact state of harmonic oscillator, including normalization factor. First, you need to find one inner product, okay, using that one, okay, pick up. Or you do one thing, you apply your ladder operator. You guys are good at ladder operator, isn't it? Pick up. You apply your ladder operator method. There is one expectation x will, not expectation x, okay. Expectation x is 0 in case of harmonic oscillator, isn't it? What will happen is you will end up with one integral like this, okay, psi naught x cap psi 1 like that, okay. Speak up. This kind of integral will come. You apply ladder operator so that because psi 1, I mean psi naught, I suggested all of you to remember including normalization, isn't it? Psi 1 I didn't suggest, okay, because very rare. But in this question it is required. But again, wherever this harmonic oscillator integral come, you can explore ladder operator. You apply ladder operator and solve that integral so that you can avoid psi 1 including normalization factor, okay. That's one part. After that, you need to do one more integral, okay. I think that is according to that time dependent perturbation theory. So transition probability, we write C1 of t mod square, okay. Probability of ground state to first exact state like this, okay. This C1 of t, okay, that's some integral minus I by h bar, speak up, 0 to t, h dash 0 1 of t. This is one inner product actually, or one matrix element you can say, okay. Pick up e power I E1 minus E0 by h bar into t actually. Energy level difference divided by h bar into t. He calls that one as omega naught. In the theory, he calls that one as omega naught. Okay. So this h dash 01 is nothing but, pick up, doable. Okay. I mean, for 5 marks, it is worth doing this one. I mean, if it were in 3.5, it was quite lengthy. So, and again, now I am thinking that you can explore this ladder operator. While doing, I solved by taking the wave function. It's not required. Okay. I mean, you have to generate the ideas. Okay. Speak up. So that's why. So this h dash of 01 is nothing but, look at here, psi 0. So this h dash of t, that is your time dependent perturbation term in the Hamiltonian. Okay. Speak up. Into psi 1 1. Okay. Speak up. So here you can take time term one side, other term other side. That x will come here. Okay. X will come here. Time term will come outside. Okay. So that's h dash of 01, h dash of 01 of t. Okay. This is a time dependent what you call part of your Hamiltonian. Okay. And this integral, what he's asking is what is the probability at one particular time? This is the probability at time t. Okay. Probability of transition. Okay. At time t. Look at here. Probability of transition is same as probability of finding that one in the state 1. He's asking what is the probability of finding that one in the first exact state at later time. Am I right? So now he has given t is equal to 2 pi by omega. Am I right? Pick up. Now you take this limit 0 to 2 pi by omega only. Because so here some exponentials will come. You need to take mod square of that one. That would be quite difficult if you are taking generalized what you call integral, and then taking mod square would be lengthy. Just try that out. So that's why while solving the problem itself, you take t is equal to 2 pi by omega. While solving this integral, so that you will get very simple complex quantity here. You take mod square, you will quickly get the answer. Or if you keep this t as it is, later if you substitute t, that would be lengthy. That's what I'm saying. Okay, speak up. While doing the problem itself, you take this limit. Okay, I mean, so keep t as it is, substitute that one. Later you substitute t. That's not a good idea. Here itself it will be simplified. Is that okay? Speak dt here. Speak up. I mean, it's also worth. I mean, if you have practiced this one, or if you know this theory, it's also worth trying at the end. Actually, you have to leave all of these difficult questions at the end of your solution. And one more. Let me solve one more problem. So this was some MIT Princeton question you can find in YK element. All speak up. V of x is equal to g x power 6. Okay, x is between minus infinity to plus infinity. He has taken g is greater than 0. So system of n particle. Okay, he's asking what is the equilibrium heat capacity. Okay, you have to find equilibrium energy. Take temperature derivative. That's the heat capacity, isn't it? Speak. No. Now look at here. This. Okay, you have solved that generalized problem. Oh, that's good. That's a Princeton question actually. Okay. That x power n, am I right? Speak up. So g of x power n. Okay. If you remember that generalized formula, that's good. So otherwise, look at here. Your energy is equal to p square by 2m plus g into x power 6. Am I right? Pick up. So what is average energy? This part of the average energy, p square by 2m, that's equal to half one dimension. Okay, px actually. Okay, one dimension. Half kb into t, isn't it? Why? Equipartition of energy. And if average value of quality term is half kbt. So to find g x power 6, I think you can work out this one. Suppose if you don't remember the generalized answer, okay, that's equal to integral minus infinity to plus infinity, okay, g x power 6 into e power minus beta g x power 6 dx, okay, divided by integral minus infinity to plus infinity. So e power minus beta g x power 6 dx. Am I right? Pick up. Way of finding any average value, isn't it? Pick up. Actually, other portion will come, those integral will get cancelled in the numerator and denominator, isn't it? Now, look at here. So, one more trick that you need to explore here while solving this integral, that is given in the reef very well. Can you guess that one? To make it in terms of log. You can write it as minus d by d beta, okay, of minus infinity to plus infinity, e power minus beta g x power 6 dx, okay. So by integral minus infinity to plus infinity, e power minus beta g x power 6 dx. So I solved this integral, just check out, okay. I mean, you don't need integral value, because later what you do is you take, some log will come here, speak up, you take derivative, right? Speak up, you take some derivative of something. So that's why it is not completely required, okay? Speak up. I mean, to solve that integral, you need only one variable. Speak up. So that's why now this part of the integral, look at here. Are you getting this idea? If you take beta derivative, you get g x power 6 outside with one more negative sign to balance that negative sign. Now this integral to be solved. Now this answer is, look at here, g x power 6. Look at here. That is minus d by d beta of log of this integral. Because e power minus beta g x power 6 dx, isn't it? Look at here. That's what I'm saying. You don't have to remember that integral because you have beta derivative here. So only that beta variable is required. You substitute beta g x power 6 equal to something, or you convert that into 2 times 0 to infinity. Okay? And you substitute something, you take some beta function outside, that's sufficient for you. Speak up. And this integral is the integral that he mentioned in the earlier problem. Okay, speak up. What is that? I mean, if you convert 2 times 0 to infinity, it's a even function. So 0 to infinity, what is that? E power minus x power 2m dx. Pick up. Isn't it? What you can do is, you can substitute beta g x power 6 as y power 6. Okay, x power 2m. So that you can grab that beta term outside. That's the only thing. We have done similar integral of taking beta term outside in the debate theory and all, isn't it? Very similar idea. Okay, and you take a derivative, you got this part, you can add those two. Okay, or you better to add that integral to your table. This integral to your table, not like this. You better to place one coefficient. Usually coefficients will be there, am I right? In our physics example, am I right? So that's why you better to add this integral. I think I have mentioned this integral in the web page. Just check that out. What is this one? E power minus some a x power n dx. Okay. I mentioned this integral. Gamma of 1 by n would come, I think. Okay. So 1 by, I think a power 1 by n or something will come. Okay. You better to, what you call, remember that integral. This particular integral. Now look at here. Let us close this discussion anyway, because I already uploaded most of the solution. You can look into that one. So anyone who finds any error in our solution, you can please send us email. We'll quickly correct that one. And one more thing is, look at here. Wait a second. So when I solved myself, okay, I could also do around 110 to 115 marks, okay, maybe 120, because some question by just seeing I can answer because of my, what you call, experience, isn't it? Speaker. Now you guys don't have that much experience to, what you call, solve like me, what I do, isn't it? Speaker. So that's why I can go, I think, up to 150 marks when I solve that one, using my experience. Okay, speaker. Using this speed and all, I can go up to only 10. Okay, 110, 110 to 120, not more than that, because some questions require to solve, isn't it? Speaker. And my way of approach is, I will not remember any formula. I will do at that time only. Okay, so then any formula based question I will leave that, and that's how I attend the exam. Okay, speaker. So so look at here. I didn't have this kind of session earlier because it's not about showing off that how I solve the problem or showing off my skills. Am I right? It's all what my student show off in the exam hall, isn't it? So that's why. So I never came online to solve that exam questions soon after the exam, or soon after they give the response sheet and all, because it doesn't matter. Because after the exam, by sitting here, with a calm mindset, anyone can solve. Even you can solve now 130 marks. Okay, or if I give similar paper, or if you see another paper that they have conducted in the other exam, you can solve 130 marks. It's not a big deal for you. So it's about how our students, okay, you guys solve or perform well in the exam hall. That's what I want to concentrate on. So because while solving the problem, I may use my experience also, isn't it? I can just when I saw that this last question, phase trajectory, within no time I quickly point out that it has a minima at x greater than 0. I pointed out the option. Half a minute it took for me to solve the question. So now again, how you guys can crack the exam, this kind of exam. Okay, so look at here. You can think like you practice all old paper, get it done. No, it's not like that kind of paper. Some repeated question, okay, some very simple question, okay, but to score after 70 marks, okay, you go up to 70 marks. You can go up to 70 marks somehow. After 70 marks, whatever the question you choose, okay, there comes your skill, your conceptual knowledge, your effort. There comes 70 to 90 marks. Are you getting speak up? Scoring 70 marks is nothing here. Are you getting in this particular paper? Because there are many simple questions, okay, analysis kind of question, or some question that even though it is difficult, you can solve some question, okay. So after 70 to 90, that 20 marks question, suppose you take 4 5 marks question, or you take 2 5 marks or 3 5 marks question, 1 or 2 3.5 marks question. Those 70 to 90 marks, okay, even though it's only 20 marks, you need to solve this kind of question. That will happen in most of the exams because it's all competitive exam, right? Up to one level, everyone will solve. So next level, again, how much effort you put, how much understanding you have, how much practice you have done. Okay, at that time, how much idea you can generate. Okay, these are all does matter. That is the competition. So that's why. So what I'm saying is this kind of paper you can crack if you have solved textbooks. Because look at here. I mean, that is that Griffith's problem that I forgot. Okay, if you guys didn't solve that problem, you should go to jail. Okay, because we discussed that one during the revision also. That two what do you call metal thing which is embedded. So we solved that one during revision also. Anyone from 1 year course who have done electrodynamics? Have you done that one? Because there will be always problem directly from the book. So and during revision we have done that what do you call Zener, and we stuck there because he didn't explain properly. We stuck there, and then I did explain again. I remembered it's a no bias situation. Potential is 0 when that silicon diode is open. Potential is 0 because Zener diode is in no bias situation, not open. So that no bias means V equal to 0. And again, these two problems directly came from that, isn't it? Speaker. These two problems. I mean, 10 marks. The competition is there only. Are you getting point? 70 marks, you got it. Are you getting? Competition is there in that 10 marks. Okay. So that's why solving book is always helpful. Is that okay? One direct Griffiths question. These are 5 marks question. Am I right? Pick up. What about that capacitance question? 3.5 or 5 marks? Okay, Zener diode is 3.5. Capacitance question is 5 marks. Am I right? So capacitance question is 5 marks. I mean, those two questions, I mean, you should never miss. I mean, when you solve the textbook, at least 2 to 3 questions nobody can solve. I mean, those who studied only old question paper, they may not able to solve. You guys can solve. That you should never miss actually. Okay, so that 5 marks plus 3.5, 7.5 marks. I mean, most of the students will not quickly do those problems. Okay, pick up because that 67 question, that two metallic objects which are embedded, it's quite tricky question. I mean, you have to apply integral of j dot dA, then that will be converted into Gauss law actually. When you apply j equal to sigma into E, it's quite tricky question. It is solved very well in exactly Griffith's question only. Okay, he also given what you call discharging condition. Okay, in the same question. So these things, I mean, you should never what you call miss. Okay, so that's why solving textbook it is must. Okay, so to crack this kind of exam, one thing, and other one is look at here. You should while preparing, okay, you should have got grinded enough. Grinded enough means you should have put yourselves to many challenges, challenging problems, because here there are at least 3 to 4 problems just by analysis you can solve. It will not require much theory or something, isn't it? And one 5 marks question on that capacitor, that CRO kind of what you call construction, isn't it? Speak up. It just requires one analysis. That means you have to read the question properly. You have to generate idea at that instant of time. I mean, it will not come in any theory. Are you fine? Speak up. So that's why, I mean, you should put yourself into lot of problems, new problems. Okay, not problem. I mean, lot of puzzles actually. Okay, so that's what I'm talking about, grinding yourself. So when you put yourself to that lot of challenges, you will have kind of quality of solving puzzle actually quickly. You will understand the problem quickly. You'll try to what you call do something and solve the problem. At least 2 to 3 problems that can be solved. Okay, it doesn't require what you call any theoretical conceptual ideas. It requires what you call you should have grinded enough earlier. You should have that puzzle solving mindset or that kind of what you call attitude, how to say skill. Okay, so that will always help in any competitive exam, especially in just in TFR, especially in TIFR actually. When you see the problem in one perspective, problem is nothing. How do you see that problem in that perspective? That means you should have grinded enough to see that in that perspective. Are you getting fine? Speak up. So that kind of questions are there. So that's why along with solving textbook, you should solve this YK-LIM, you should solve, I mean, any what you call problems, more and more problems, tricky problems, so that, I mean, that puzzle solving mindset that should be there. Okay, that will also help to qualify this exam. So third one is practice, because there are many questions. Suppose if you take that muonic kind of atom, perturbation theory question, okay, atomic physics question, Laplace transform question. Laplace transform is very simple. If you just define Laplace transform integral, okay, it is done actually. So speak up. And this relativity question, okay, relativity. You should, I mean, after all concept from the book, if you have solved problems and all from the book, you will definitely do this kind of question because it's a relativistic energy and momentum transformation. Is that okay? So I mean, cutoff may be around 85, 90 to 95. Okay, 85 to 95 that I guess. Okay, speak up. So I mean, to score that one, you don't have to solve all difficult question. You have to solve some difficult question. If you see only easy question, you may go up to 80 marks, I think. Okay, quite easy. Question paper is relatively easy. Problems are solvable. You can go up to 80 marks. I think 90 would be the cutoff. So for JRF, I guess for JRF, okay, 90 to 90 is the cutoff. That's what I'm guessing. Okay, so but from 80 to 90 or 100, okay, that's what I'm saying. That 80 to 100. That question, whatever you choose, that is the competition. Are you fine? 70 to 80 marks is easily what you call scored in this kind. Any of the paper, anyone who prepared, they will score 70 75 marks. Okay, pick up. But look at here. And next thing is you guys have to do mistake analysis soon after any exam, whatever you attend. Not only soon after that exam, you have to what you call do mistake analysis after each and every test. Okay, suppose if you have attended what you call 120 marks, if you have done a lot of mistake, you are out of the competition. If you have done many mistakes, you are out of the competition. That's why, so you should do mistake analysis. That mistake may be choosing a difficult question. Okay, rather than there was already easy question, you have chosen difficult question. That's a mistake that you do in the exam one. Okay, pick up. Or you don't know concept well, but still you try to solve the problem, try to guess the answer. That's also mistake because you have negative, isn't it? Pick up. And suppose again you have studied that topic very well, but you couldn't solve. Okay, so that means that concept is not digested well, or you can't apply that concept. You should go back and work on that one. So now look at here. I mean, whatever the suggestion that I'm giving, I mean, you should note it down. Okay, you should do that one. You should execute that one. Soon after the exam, you have to do a proper mistake analysis. What you do is while doing practice test, you do the practice test, you count your marks, you will go to revision, isn't it? Speak up. During revision, you will do like that. You will not have patience to do mistake analysis. But mistake analysis is the most important part. You have to at least spend 1 more hour after 3-hour practice test. You have to spend at least 1 more hour in analyzing the mistake. Why mistake happened? Why I couldn't score enough? Okay, why I left those difficult. Sometimes you couldn't read the question properly. Am I right? I mean, if you didn't read the question properly, that's also a mistake. Am I right? So now look at here. It's a competitive exam. You can't do any mistake in exam hall. If you do more mistake, you are out of the competition, even though you prepared very well. So that's why. So I mean, you guys are matured enough to find the core reason of your mistake. Am I right? That may be conceptual mistake. That may be mistake in being lazy in writing the step sometimes. Is that okay? Speak up. If you are lazy in writing the step, if you try to skip the step, usually mistake will happen. Okay. Suppose loss of concentration, or you might not have read question properly. Lot of mistake that can happen. That should not happen in the exam hall. So along with this kind of preparation, okay, solving textbook, understanding the concept and all. So at the end, you should do enough practice test and enough mistake analysis, because psychologically, when we write it down, our mind will be more aware of that one. You will not do the same mistake again. Okay, you write down, I didn't read this question properly. You write it down 10 times. Okay, after the while doing mistake analysis, you write it down 10 times. Okay, pick up. I didn't read this question properly. So, I mean, while solving that one, I also didn't read one question properly. That is this quantum mechanics finite well problem. Actually, I didn't see infinity one side. I was seeing zero in the both side. I couldn't get cot function quickly. Okay, speak up. So, I mean, if you are not reading the question properly, so you write it down. I didn't read question properly, because psychologically, when you write it down, your mind will be aware of that one. You will not do that mistake again. Okay, pick up. And at least you should do 10 practice tests, 3-hour test. After that, you should spend 1 hour to do mistake analysis. And by the end of that one, you can avoid those what you call mistakes in the exam hall. Is that okay? Speak up. So because suppose if you attend 130 marks, if you do what you call 6 to 7 mistakes, okay, in 5 marks, you are out of the competition. Okay, so that's why solving book is not optional. Okay, solving book is not optional, it is must. Okay, to crack this kind of exam. To, I mean, not only that, I mean, you have seen last gate paper, am I right, how conceptual it was, those multiple selecting question and all. Okay, that's why solving book, understanding concept, these are not optional. Okay, you have to do it. And again, in our website, you can find all detail about what are the books you need to solve. And in our, I think, YouTube playlist, you can find enough videos to kickstart your book learning. Okay, speak up. That is must. And next one is, along with those books, okay, you need to solve problems like YK-LIM. And there is one more book here, Guide to Physics Problems. A Guide to Physics Problems, Part 1 and Part 2 by Sydney B. Kane. Okay, so this also very similar to YK-LIM book, either YK-LIM or this kind of book. And along with that one book problem, that Griffiths problem, Reef problem, Ghostin problem, okay, Griffiths electrodynamics, quantum mechanics problems, okay, Jetili problems, okay. So solving book problem will always help in the exam, because you will definitely get 3 to 4 questions directly from the textbook. And nobody, I mean, those who didn't solve the problem book, okay, they couldn't solve those questions. They may not able to solve question. Then you will be little bit better than them in the competition. Okay, so that's one part, solving textbook. Other part is speak up. I mean, why kill him this kind of question? Okay, so third one is practicing more and more MCQs, because I mean, this book problem will help you to understand, isn't it? Help you to digest, help you to apply also. But applying the same thing in MCQ is a little bit different, isn't it? Pick up. Sometimes it may be straightforward, as in the book problem. Okay, sometimes you don't have to solve the problem. You just see the option and you can eliminate the problem. Sometimes you can do halfway solution and you can try to match up with the options and all. That requires practice, okay? And avoiding mistakes and all that comes what you call in the practicing MCQ. If you do all of them, I think you can crack the exam. Okay, so just keep these things in mind and try to prepare for next exams. And all of the solution, most of the solution, okay, maybe around 90% of the problems that I have uploaded to website, you guys can just check that out. And if you have any comment Okay, just comment on it. Okay, so I will never compromise on physics while solving the MCQs. Okay, because so recently we have planned to solve old papers. Okay, because the material which is available in the internet, that contains lot of mistakes. They compromise with the subject to get into the answer. Is that okay? That you should never do. That attitude is you will never survive. Okay, with that attitude. Okay, because now look at here. I don't think there are much mistakes in the question paper. Okay, they have designed better in last question papers and all. In each question paper, 3 to 4 mistake you can find actually. Apart from while conducting exam they did mistake, that's a different story. They didn't give calculator, that's a different story. But questions are, I mean, very good design, very well designed. Okay, so then in that case, if your attitude is not good of applying the concept, okay, I mean that's a wrong attitude. Okay, I mean try to match up with the answer. Okay, speak up, don't develop that attitude. So that's why try to solve new question. Okay, try yourself to push yourself to new question. Okay, uh, and later after solving the question, you try to what you call match up with the answer key. Okay, pick up that attitude. If you develop, I think day by day you will improve and you will face that competition. That's why. So while solving what you call these MCQs, I have given reference. Okay, from which textbook I have taken it from, what are the concept that is involved here. Okay, it's not matching up with the answer key. Okay, whatever solution that we have prepared, it's not matching up with the answer key. Okay, and if question is wrong, we will mention that question is wrong. Many old papers have got lot of mistakes. Okay, and those I mean, even though questions have a mistake, many people have put up the solution and try to match up with the answer key whatever they have given. Somewhere they have compromised with the subject, I mean in between the step and all. Okay, so don't follow those kind of things. Try to develop your own ideas. Okay, if question is wrong, it is wrong. Question is right, again it is right, like that. Okay, I mean subject is more important than those questions. But I mean those are old question papers. Okay, but when I see last gate paper, when I see this CSIR-NET paper, okay, I mean questions are very well designed. Okay, so with a right attitude you can definitely crack the exam. So try to develop those qualities. Okay, yeah. Okay, we will see in some other session. Those who are new to this session, please share information about our coaching class, our method of learning, and our YouTube channel, where around 20% of the videos are there free to watch. That is enough to kickstart your what you call preparation. Okay, those 20% of the resource. I think 2 to 3 people have sent me email that these that only 20% of the video that I uploaded, that has helped them to qualify GATE exam with not good ranking, but help to crack the GATE exam. They said like that. Okay, because understanding is very important in any exam. So I hope this YouTube video will help you. I think using that you can solve first 2 chapters of Griffith's quantum mechanics. I think first 3 chapters of Griffith's electrodynamics. Full of Lagrangian mechanics videos are there in the playlist. Okay, so you guys can make use of that one, and please share with your juniors. Okay, speak up. I mean after COVID, lot of YouTube channel emerged. Okay, so that's why usually the I mean students are what you call following different channels. Okay, which is not so standard in concept and all. Okay, they do a lot of mistake, but I don't comment on it because everyone is putting their own effort. All coaching classes are putting their own effort, so that's why I don't comment on their mistakes. Okay, so what I am saying is, again, you guys please share with others. Okay, these YouTube resources with your juniors usually, because during COVID you didn't go to college and there is no link between junior and senior, isn't it, speaker? So that's why, again, your junior didn't ask which one to follow, isn't it, speaker? They followed which came to our screen on Facebook, YouTube, or something. So that's why recently I'm concentrating on how to train students well, and we are building some resources also, MCQs and all. So that's why I don't have much time to do this YouTube marketing. So that's why, I mean, those subscriber whatever I have, okay, you guys have to spread it to your juniors, okay, and whatever the WhatsApp group, whatever the Facebook group you have, if you share that one, I mean, you just suggest them to follow this one. These are very similar to these lectures, okay, whatever the effort I put, that are very similar to your NPTEL course actually. I mean, up to that one, up to that level actually. So that will definitely help to understand something during MSc and all when they have time, okay. Yeah. So cutoff that I guess is 90, okay. 90 is my guess, but it can be only guessed, okay. Speak up. Hmm? It may be less than that also sometimes, okay. Speak up. Last time we guessed bit high cutoff, but cutoff was quite low because during COVID nobody studied well, okay. But this time many people have studied and gave a very good attempt. That's why I'm thinking around 90 is the cutoff, okay. So whatever, all the best for all of you for next TFR exam in the month of December, and GATE exam, and JUST exam, and JAM exam. So I hope one more CSIR-NET exam will happen in the month of February. So all the best for those exams also. So if you have scored well, all the best for the interviews, okay. If you didn't score well, I hope you will do your mistake analysis and correct that one, and get the quality whatever required to crack the exam. Get the, what do you call, develop the skill whatever required for the exam. We shall see some other day on this YouTube live.